Hello students, welcome to Vipin Sharma online class and in continuation with the chapter Units and Dimension. Dear students, I'm going to tell you, rather define and explain you principle of homogeneity. See, what is principle of homogeneity? See, principle of homogeneity states what? It states that dimensions of mass, length and time on the left hand side of a dimensional equation must be equal to the respective dimensions on the right hand side. Basically, this principle of homogeneity matches with the concept of indices of mathematics. When you people study mathematics in lower classes, so you might come across this concept: if a to m is equal to a to n, then m is equal to n. So, for example, like you people write x cube is equal to 8, then x cube is equal to 2 to this power 3, then x is equal to 2. It simply explains that dimensions of mass, length and time on the left hand side must be equal to the respective dimensions of mass, length and time on the right hand side. That is, x is equal to a, y is equal to b, z is equal to c. So this is what the principle of homogeneity. If you put the definition, well, you will have to write: principle of homogeneity states that dimensions of mass, length and time of left hand side must be equal to the respective dimensions of mass, length and time of right hand side. Well, students, this concept leads to the progress in units and dimension in a very unique way. You'll put a question: what do you mean by, sir, in a unique way? Let me take it out first, because if I'm writing with a quote, it troubles me. Let me teach you without this, because it restricts my writing. When we talk about the dimensions of mass, length and time of left hand side must be equal to the respective dimensions of mass, length and time of the right hand side, what this principle of homogeneity helps us, it enables us to have three uses of dimensional equations. You all know what is dimensional equation. Like, when we equate the dimensional formula to the physical quantity, then it gives rise to the dimensional equation. The first uses of this is to check the correctness of a relation. To check the correctness of a relation. Now you'll put a question: sir, what do you mean by to check the correctness of a relation? Look, suppose we have this relation S is equal to UT. You all know what is S. That is distance, if in a particular direction and along a straight line, then it is displacement. You'll put what is u. A question, what is u? U is basically an initial velocity, right? And you'll put a question, what is t? That is time. Now I will take the left hand side, that is s. S is distance, this m0, l1, t0. I will take the right hand side, that is ut. That is l1, t minus 1, t to 1. This is m0, l1, t0. You find that dimensions of mass, length and time of the left hand side is equal to the dimensions of the mass, length and time of that of the right hand side. Now we have ut plus half at square. Suppose if you have to find the dimensions of, check the correctness of s is equal to ut plus half at square. So what do you find? You find that this is s is equal to ut plus half at square. How it is accurate, how it is correct using the concept of the dimensional analysis. You take left hand side is s m0 l1 t0, but right hand side is ut plus half at square. Ab half is what? Half is dimensionless. Half is dimensionless. What is acceleration? L1 t minus 2 and times t square. So this is again L1 T0. So you will find M0 L1 T0, because if length plus length is length, chalo, it doesn't matter, T to 0, right? M to 0. Length plus length is length. Somebody will say it must be 2 length. No, it is not going to be 2 length, because 2 has no dimensions. These are constants. The constant has no dimensions, right? These are called dimensionless constants, like numbers 1, 2, 3, 4, 5. These are called what? Dimensionless constants. So hence left hand side and right hand side have got the same dimensions. This is correct. Similarly, you can do v is equal to u plus at, v square minus u square equal to 2as. So you can do it as an exercise. Now, students, I'll tell you something, a very simple, point to understand, that mass plus mass is equal to mass. You will say, sir, it is 2 mass. You will not write here 2. No, it has no value. Because 2 is a constant, it has no dimension. Mass minus mass is again mass. Length plus length, again length. Length minus length is length. Time plus time is again time. Time minus time is again time. So, dear students, you will find that this is going to be something, what do you say, this is going to be length minus length, you will say 0 length. 0 has no dimensions. 2 has no dimensions. 10 has no dimensions. These are called dimensionless constant. In the progress of the chapter, I will tell what are dimensional constant also, and what are dimensionless constants. So all numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, these are all called dimensionless constants. And the numbers which are like anything like trigonometric sine theta, cos theta, tan theta, secant theta, cosecant theta, these are all dimensionless, but has units. So these are dimensionless but has units, like angle has got a units in degree, radian, grad. You generally discuss in degree and radian, but you don't discuss in grades. That is now not in syllabus. So you can check the correctness of any relation using this concept. Hope it is clear. So there are so many questions based upon to check the correctness of the relations. Actually, the concept of the dimensional analysis says that like adds like adds like subtracts like. So you can add mass into mass, you cannot add mass into length. You cannot add mass into length. You can add mass into mass, you can add length into length, you can add time into time. You can multiply mass with length and time, but you cannot add mass into length and length into time. So this is how we find the check the correctness of the relation. One exercise I am giving you, A plus velocity is equal to U. I write say capital A. A plus velocity is equal to U. What is the dimension of A? Like adds like. So velocity will add velocity. The dimension of A will be L1T minus 1. It will be L1T minus 1. This is all about a simple concept I have told you. Need not to confuse much about this. And what is principle of homogeneity? Principle of homogeneity states that the dimensions of mass, length and time of the left hand side must be equal to right hand side. And what is uses of dimensional equation? The first uses is we can check the correctness of the relation. Like we check the S is equal to UT, then S is equal to UT plus half AT square. So these are various concepts. Like we can check V square minus U square equal to 2AS. We can check V is equal to U plus AT. We can check so many concepts using the dimensional analysis, right? So in brief, if I make you to revise what is unit, it is the standard measurement of a physical quantity. And what is physical quantity, which can be expressed in terms of certain laws. There are two types of physical quantities. One is called fundamental quantities and other is called derived quantities. Fundamental quantities are those which cannot be further subdivided. In mechanics, we have got a mass, length and time. And derived physical quantities like velocity, like acceleration, like force, like momentum. So students, this was sufficient in this slot, and thank you very much. To be continued in the next slot.